Okay, so we looked at this whole equilateral triangle thingamabob, but now we're going to look at a square, which is also very symmetrical, except this time it has four sides. All four sides are congruent. It also has four right angles. And we're going to assume that these are right angles even though they're not marked, because, it's pretty visually convincing here that these are right angles. And in fact, they are. I just didn't draw them in before. All right, so I'm looking at a square, but now my goal is, how do I find this thing? That's a piece of cake. Piece of cake. Check this out. It's really two right triangles, and you have the two legs. So I'm going to have 4 squared plus 4 squared, the two legs squared equals the hypotenuse squared. We'll call it, I don't know, x, whatever, x squared. So that's 16 plus 16 equals x squared. So that's 32, or 2 times 16 equals x squared. And then when you wind up square rooting, you got square root of 32 equals x squared. However, we could factor out a square from that. A square that goes into 32, well, 4 goes into it, but hey, guess what? 16 does too, so 16 and 2 multiplied would make 32. Oops, shouldn't have that squared there. So then that means this is 4 times the square root of 2. So here's what's kind of interesting. Let's do this from scratch, just like that. But instead of 4, let's just kind of pick like any old number. And any old number in the world of math has an actual name. We call it a variable. So I'm going to have a straight line going across here. And now I'm going to call these, like x and x. And I don't know what this is now. Well, but I know that those are the same because it's a square. So I would have x squared plus x squared equals the question mark squared. Well, that's like 2x squared because you got 1 here and 1 here. So 2 times x squared equals the question mark squared. The same way that it was like 2 times 16, except it was x. And now I could square root. So if I square root both sides this time, something interesting happened. The square root and the squared, those are inverse operations. So now we're just back to good old question mark. On the other side, though, we got kind of a mixture of things. We got the square root of 2, and then we have the square root of the x times itself. So I'm going to simplify square root of x squared, and that's just x. So the square root of 2 times x is our question mark. But wait a second. I usually write the x out here. So if I were to say x times the square root of 2 equals the question mark. There we go. That looks pretty solid. So this would be x times the square root of 2. All right, so that's that's not x divided into 2. X times the square root of 2. That's kind of interesting, but let's see how this plays out like in some of our practice problems. So here's some practice problems for us. We're going to go ahead and draw on these. Let's zoom into this first one, number 21. So we got this big old thing, and you'd think, oh my gosh, it's 45 degrees. That means, oh my gosh, this is 90 degrees. And if I were to do the calculation, I would come up with 45 degrees. But this special kind of pattern here, 45 and 45, that's really half a square. It's not really a triangle, it's half a square. Let's get more accurate. Let's do some straight lines here. So we got a straight line there, and then a straight line up. Excellent. It's half a square. Why is that important? Because I know something about squares. I know that the opposite sides are the same, and I know that all four sides are actually the same. So this up here is 4 root 2, even though I didn't know what it was, but it was given to me. They didn't tell me these were the same, but because these are 45, 45, 90 triangles, that means it's half a square, which means all 4 of those legs would have been the same. All right, that's cool because now I could find x, which I don't know what it is, but I could find it. It's really not as hard as you think. So let's see if we can give ourselves some workspace here. We know that the leg squared plus the leg squared is going to equal the hypotenuse squared. So let's just fill those in. That would give me 4 times the square root of 2 quantity squared plus 4 times the square root of 2 quantity squared equals x squared. All right. Not too bad so far. We just got to do some arithmetic here. So 4 times 4, that's 16. Square root of 2 times square root of 2, that's 2. That's how we're coming up with this piece. And then we would get the same thing over here, 16 times 2. Add those together and we got x squared. Well, 16 times 2, that's 32. And then we got another 32. And then we got x squared. Well, those give me 64. Well, the square root of 64 is just 8. So x equals 8. Piece of cake. So right here, x, this equals 8. Done! It was that easy. You want another one, you say? Okay, if you really want it. Let's do one that's a little bit different. How about 25? How about 25? We'll zoom in on this one. Okay, so I'm looking at 25. It says 2y and x, but I know that if that's 45, that means that this other one is also 45 right here. And then I could draw like a line, and it's going to go off the page, but that's okay. And this would go down there, and that would make a square. You know what? Let's redo that from scratch. Let's give ourselves a little more workspace here. That's better. Okay, so I'm going to draw the 2 missing legs of this square, the 2 missing sides. That looks a lot better. So that means that this was 45 and that this was a square all the way around, because 45, 45, 90 is really half of a square. What does that mean? Well, that means that 2 and y are the same thing. That was a piece of cake. That was so easy. But the question is, well, what's x? How could I figure out x then? Well, this is just Pythagorean theorem again. So 2 squared plus 2 squared equals y squared. Cool. And then that means 4 plus 4 equals y squared. 8 equals y squared. And then we take it even further. We square root. We've got square root of 8 equals y. That's good. That's not bad at all. But hey, I think I could factor out a square from 8. And in fact, I could. I could pull out a 4, which would leave me left with a 2, because 4 times 2 is 8. And 4 is a perfect square, which becomes just 2. So it's 2 square root of 2 equals y. And then that's that. So that was cool. Whoa. Whoa. This is x. Y. What? These are all x's. X, 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 x. So x equals 2 square root of 2. We could have also just said square root of 8, but for those nasty, how do you say, or what do we say? Those nasty multiple choice questions, they like to simplify. And there you go. That's it. So half a square. Remember, you got that symmetry. These two sides are the same. And then you can use Pythagorean theorem to find this. Or work your way backwards the other way.